If you can, just for a moment, let yourself settle. Take a slow, deep breath. Let the noise and the hurry of the day begin to fade like a distant sound growing softer. There is nothing you need to do right now, nothing to figure out. All you have to do is be here and listen. Have you ever stood outside on a clear night far away from the lights of the city and just looked up? There is a unique feeling that comes with it, a profound and silent stillness. You look up into that deep, endless black and you see them thousands, perhaps millions of tiny, shimmering points of light. They feel so far away, so untouched by our small, busy world. The air is cool. The only sound might be the gentle rustle of leaves, or perhaps just the sound of your own breathing. In that moment, the world feels vast, and we standing on this little planet feel so small. But it is not a bad smallness. It is a quiet smallness. A smallness that connects us to something enormous. For thousands of years, humans have stood exactly as you're imagining, looking at those same stars, feeling that same sense of wonder. And in that great silent wonder, questions begin to surface. They are not the loud, demanding questions of our daily lives, questions about schedules or work or what to do next. No, these are the big questions, the quiet ones that sleep beneath the surface. Who are we? What is this place? Are we alone? What does it all mean? These questions are not new. They are as old as we are. They are the universe itself, whispering to the part of it that has learned to listen. That is the whisper from the cosmos. It doesn't shout for our attention. It patiently waits for us to get quiet enough to hear it. Tonight I invite you on a journey. Not a journey across space, but a journey of the mind, a journey through thought. We are going to gently take hold of those big questions. We are going to explore the strange and beautiful reality that we find ourselves in. We will talk about the universe, about this grand cosmic story and our place within it. This isn't about complex math or dry facts. It is about the feeling. It is about exploring the very nature of life, of our own awareness, and how we fit into a picture so vast, so strange, and so much more wonderful than we can possibly imagine. So let your mind relax. Let your curiosity open. There is no test at the end. There is only an invitation to wonder. Let's step away from the everyday and just for a while listen to that whisper. Let's explore the reality of our lives and our place in this magnificent, mysterious cosmos. Find that comfortable space, the one where the world outside seems to fade. Let the weight of the day settle, release the tension from your shoulders and just breathe. Tonight we aren't just looking up at the stars. We are going to look sideways. We are going to gently pull at the very edge of our reality just to see what might be behind it. We are going to talk about the quietest, most profound, and perhaps most unbelievable idea in all of physics. An idea that suggests this, all of this, might not be all there is. We're going to turn the pages of a book we never even knew existed. The idea of a parallel universe feels familiar. It feels like something from a story from a comic book or a late-night movie. A world just like ours, but different. A world where you made a different choice. A world where the great tragedies of history never happened. Or perhaps where worse ones did. It's a wonderful, fascinating story, Roro. But what if it isn't just a story? In the quiet, hallowed halls of physics and cosmology, this idea isn't fantasy. It is a genuine possibility, one that is whispered by the very mathematics we use to understand our own reality. The equations that describe the Big Bang, the equations that govern the strange behavior of tiny subatomic particles. When you follow them, truly follow them to their logical end, they don't just point to our universe, they seem to be screaming about others. Now when we say parallel, it's easy to get confused. We're not necessarily talking about extra dimensions, like the tiny curled-up dimensions suggested by string theory. That's a different, fascinating idea for another night, that our world has more than just length, width, depth, and time. No, the idea of a multiverse is often bigger. It suggests whole other realms, other entire universes, existing alongside ours perhaps, or perhaps just incredibly impossibly far away. Let's start with the simplest, most straightforward idea. Our universe is vast. We can only see so far. There is a horizon, a limit called the observable universe. This is simply the distance that light has had time to travel to us since the beginning of time, about 13.8 billion years ago. It's a massive sphere and we are at the center of it. But what's beyond it? What lies past the edge of what we can see? The simplest, most logical assumption is that it's just more of the same. More space, more stars, more galaxies stretching on, perhaps stretching on forever. If space is truly infinitely large, then the rules of statistics take over. Think about it. If you have an infinite number of chances, anything that is possible will happen. Not just once, but an infinite number of times. Somewhere out there, far beyond our sight in that endless black, there could be another region of space, another galaxy, another solar system, and another planet that is an exact copy of Earth. And on it, an exact copy of you, and another, and another. And there would also be a universe where you are almost identical, but you chose to wear a different colour shirt this morning. A universe where you took that job you turned down. A universe where you said yes instead of no to that one defining question. This isn't a magical realm, it's just a consequence of infinite space and finite possibilities. But we can go deeper. The theory that describes the explosive birth of our universe is called inflation. It suggests that in the very first fraction of a second, our universe expanded faster than the speed of light, from something smaller than an atom to something larger than a galaxy. A modern version of this idea is called eternal inflation. Picture the multiverse as a vast cosmic ocean bubbling and foaming. Our entire universe, everything we have ever known or seen is just one of those bubbles, but the ocean itself, the fabric of space-time, is always inflating, is always expanding, and as it expands, it is constantly creating new bubbles. New universes, each one a new Big Bang. Bang. Each bubble is a new self-contained cosmos. Perhaps these other universes are like ours with the same laws of physics, but perhaps they're fundamentally different. Perhaps they have stronger gravity or weaker light. Perhaps atoms could never form at all. They are distant, separate, and we can never ever reach them. We are just one bubble in an infinite cosmic foam. Now, let's talk about the strangest idea, the one that feels the most personal and perhaps the most unsettling. It comes not from the vastness of space, but from the ghostly, uncertain world of the very small. It comes from quantum mechanics. You see, on the smallest subatomic scale, reality is fuzzy. A particle like an electron doesn't really exist in one single place until you look at it. Before you measure it, it exists as a wave of probability, a cloud of possibilities. It could be here or there, or spinning up or spinning down. When you finally look, when you measure it, the particle seems to choose one reality. It solidifies, it becomes real. But what happens to all the other possibilities? The electron that spun down instead of up, the path not taken. In the 1950s, a physicist named Hugh Everett proposed a radical idea. He suggested that the universe never chooses. Instead, it splits. Every time a quantum event has more than one possible outcome, the entire universe divides. In one universe, the particle went left. In another parallel universe, it went right. This isn't happening just in a lab, it's happening right now. Everywhere. Trillions of times a second, every tiny random chance, every decision. It all branches off into a new separate parallel reality. This is the many worlds theory. It means there is a universe where you are still listening to this, and another where you turned it off moments ago. There is a universe where you said yes, a universe where you said no, a universe where you never met them, a universe where you are right now living a completely different life. It's a staggering thought. A constantly branching tree of realities growing with every passing moment, and we are all just living on one of the branches. And finally, we come to the edge of thought, the most abstract, the most mind-bending idea of all. This is the mathematical universe. This idea suggests that any universe that can be described by mathematics exists. Not just universes with slightly different physics like the bubble universes, not just universes with different histories like the many worlds, but universes with entirely different laws of nature, universes with 5 dimensions of space instead of 3, universes where gravity is a pushing force, not a pulling one, universes that are nothing but pure beautiful geometry with no stars, no planets, and no life at all. It's the idea that mathematics itself is the ultimate reality, and our universe with its elegant laws, its speed of light, its galaxies and nebulas is just one very specific, very complex mathematical structure floating in an infinite ocean of all possible structures. Why? Why do scientists, serious, grounded, brilliant scientists, even think about these things? It's not just for fun, it's because these ideas are the logical conclusion of our best, most tested theories. Inflation, quantum mechanics. They both seem to point away from a single, unique, special reality and toward a multitude. It can make you feel small, can't it? To think that our entire cosmos, all the stars we can see, all of human history, all our loves and losses, is just one bubble, one branch, one page in an infinite library. But maybe small is the wrong word. Maybe the word is connected to a possibility so vast it defies imagination. As you drift off to sleep tonight, hold that thought that our reality is a precious, beautiful thing, that it is one verse in an infinite poem, a single illuminated page in a book with unseen covers. Sleep well and wonder. And so as we float in this vast quiet space, a question naturally forms in our minds. It's the great echoing question of humanity. If the universe is so full of stars and planets, where is everybody? The silence is profound. We have been listening, truly listening for decades with our radio telescopes pressed like ears against the cosmos, and we hear nothing, just the gentle, steady hiss of the universe itself. This leads us to a new kind of wondering. Perhaps we are listening for the wrong things. We are searching for messages, for radio signals, for greetings. We are looking for ourselves, but what if we are simply too young to understand the conversation? Imagine for a moment a civilization that is not 1,000 years older than us or 10,000. Imagine a civilization that is 1 million years older, or 10 million. Our entire recorded history from the first cave painting to this very moment is just a few thousand years. It is a fraction of a second in cosmic time. What would a million years of development look like? Trying to imagine their technology is like asking an ant to understand a smartphone. It's not just that the ant doesn't know how it's built. It's that the ant doesn't even have the concept of communication of data, of pictures, or of electricity. The ant and the smartphone exist in two completely different realities, even as they share the same park. We may be the ant. A civilization a million years ahead of us might not use radio. They might not use any technology we can recognize. Their technology might be so advanced that it looks to us like a law of nature. It might look like magic, or it might be completely invisible. So how do we look for the unimaginable? We must stop looking for the call and start looking for the footprint. We must look for the evidence of their existence. Not the technology itself, but the effect of that technology on the environment around it. These are what we call technosignatures. A technosignature is the shadow, it's the echo. If a civilization builds a global industrial complex, their atmosphere will fill with chemicals that don't belong, just as ours has. We could perhaps see that from far away. We could look at a distant planet's air and see the telltale sign of smoke, even if we can't see the fire. But let's think bigger. What does any civilization, no matter how strange, always need? What is the one resource that is universal, that powers all life and all complexity? Energy. A civilization as it grows will always need more energy. It is the fundamental currency of the universe. At first, like us, they use the scraps. They burn wood. They find the buried ancient sunlight we call oil and coal. They learn to split the atom. But eventually they will look up and see the greatest power source in their neighborhood, the one they have been ignoring, their own star. A single star like our sun outputs more energy in 1 second than our entire human civilization has used in its whole history. It is an unimaginable torrent of power, and almost all of it just radiates away uselessly into space. A truly advanced civilization might decide, what a waste. This brings us to one of the most incredible and awe-inspiring ideas ever imagined, the Dyson sphere. When you hear that name, you might picture a giant solid metal shell built completely around a star, trapping every bit of light. But the physics of that are difficult. A solid shell would be unstable. It would be hard to build. Instead, imagine something more organic, more logical. Imagine a Dyson swarm. It doesn't happen all at once. The civilization just starts building powder collectors in space. Small ones at first, like solar panels in orbit. Then more, thousands of them. As their energy needs grow, they build millions, then billions, then trillions. Each one is an independent robot, a collector orbiting the star in a vast, complex, buzzing cloud. From a distance, this swarm of collectors would look like a dim, man-made nebula. It would be a cloud of technology, a living, growing net cast around the star to catch its light. As the centuries pass, the swarm grows thicker. More and more of the star's light is caught by the collectors. From the outside, the star would begin to dim. It would look like it was slowly, mysteriously going out. But here is the key. The laws of physics are absolute. You cannot destroy energy. You can only change its form. All of that starlight, all of that power is being used by the civilization inside the swarm. And what does all activity, all work, all life produce? Waste heat. Your computer is warm right now, your body is warm, everything that works gives off heat. A civilization of trillions using the power of an entire star would get very, very warm. The swarm of collectors would soak up the bright visible light of the star, but they would glow with the invisible light of heat. They would shine in the infrared spectrum. So how do we find a Dyson sphere? We don't look for a bright star. We look for a strange darkness in the visible sky, a place where a star should be. And then when we look at that same spot with infrared telescopes, we see a massive, astonishingly bright, warm glow. It would be the footprint of a civilization that is drinking light directly from its sun. It would be the techno-signature of a truly advanced species. We are looking for these. We are searching for stars that are unnaturally dim but unnaturally warm. So far, we have found a few candidates. They are probably just dust clouds, but maybe not. This idea of ranking civilizations by their energy use was formalized by an astronomer named Nikolai Kardashev. He proposed a scale, a way to measure how advanced a civilization might be. A Type 1 civilization, he said, is one that has learned to control all the energy of its planet. They can control the weather. They can stop earthquakes. They can harness the power of volcanoes. They use every bit of sunlight that hits their world. By this measure, we are not yet a Type 1 civilization. We are still a Type 0. We are still at the mercy of our planet, still drawing our power from its crust. A Type 2 civilization is the one we just imagined. They have mastered their star. They have built a Dyson sphere or something similar. They control the entire energy output of their solar system. Their power is planetary solar. And then there is Type 3. A Type 3 civilization is difficult to even speak about. A Type 3 civilization has mastered the energy of its entire galaxy. How we cannot say. Perhaps they are harnessing the power of the supermassive black hole at the galactic center. Perhaps they have learned how to move stars to arrange them to farm them for energy. A Type 3 civilization would not just be building structures. They would be sculpting reality on a galactic scale. Their technology would be godlike. They would be to us not as we are to the ant, but as we are to a single unthinking atom. This scale is a wonderful way to dream. It gives us a ladder to imagine. But it also makes a very big assumption. It assumes that the goal of all life is to expand to consume to use more and more energy. It is a very human way of thinking. It is the logic of growth, but is it the logic of wisdom? This brings us to our final quiet question here in the dark. What if advanced civilizations don't get louder? What if they get quieter? What if after 1,000,000 years you don't care about building bigger machines? What if you have solved energy? What if you have solved scarcity? What is left? Perhaps the path of wisdom is not outward, but inward. Perhaps a truly advanced civilization doesn't build Dyson spheres. Perhaps they find a way to be perfectly efficient to do everything they need with almost no energy at all. Perhaps they turn their consciousness inward into vast simulated universes that exist in a space smaller than an apple. Perhaps they become sustainable, quiet, content. Maybe they don't want to be found. Or maybe they have translated their entire civilization out of the physical world and into a realm of pure energy or pure information. If that is the case, we will never find them. We could scan the sky forever and all we would hear is the wind of the stars and the echo of the Big Bang. The silence of the universe might not be an absence of life. It might be the sound of truly advanced, truly mature life. A life that has learned to whisper. A life that has found peace. And so we continue to float. We listen for the shout. We look for the footprint. And we also listen for the silence. We have journeyed so far tonight. We have drifted through the spiral arms of galaxies, watched stars be born in fiery nurseries, and felt the silent patient pull of dark matter, the invisible architecture of everything. We have touched the cosmic shore and it has felt peaceful, distant. Now let us do something that feels perhaps a little harder. Let us pull our gaze back. Back from the edge of the observable universe, past the glowing quilt of the Milky Way, past the orbits of the outer planets, back to that small shimmering marble of blue and white. Back to our home, our Earth. It too is a cosmic body. It too is governed by immense forces. But here the forces are not silent. They are not distant. They are immediate and they are growing stronger. We have been floating in the quiet void, but our planet is a place of sound and fury. We are moving from the deep, slow-breathing timescale of the stars to the rapid, chaotic heartbeat of our own world. We are coming home to face the fury that is brewing closer to us, the rise of extreme weather. What does that word even mean, extreme? It used to be a word we reserved for the truly rare, the storm of the century, the flood that old-timers would tell stories about. It was the exception. It was the event that broke all the rules. But something has shifted. Extreme is not just a bad storm anymore. It's not just a very hot summer day. Extreme is when the very boundaries of what we thought was possible are shattered. It is the fire that does not just burn a forest but creates its own weather system, a fire tornado that breathes lightning. It is the rain that does not just fall, but is measured in feet, not inches, in a single day, turning city streets into churning brown rivers. It is the heat that does not just make us uncomfortable, but buckles roads, melts power lines and silences the birds at noon. The records are not just being broken, they are being annihilated. The graphs we use to measure our world, the lines are moving off the chart. The language we use unprecedented, historic. Once in 1,000 years, we are running out of words. This is the new signature of our planet. Extreme is frighteningly becoming the new normal. It is the new unsteady rhythm of our world, a drumbeat of disruption. And so we must ask why. Why is this happening? The answer is, like many things in nature, complicated. It is a story with two authors. First, there is the planet itself. Our Earth is a living, breathing, dynamic system. It has its own cycles, its own moods. It has natural rhythms that have unfolded over millennia. The warm currents of El Niño, the great conveyor belts of the ocean, the wobble of the planet on its axis. These cycles have always brought periods of flood and drought, hot and cold. This is the planet's natural heartbeat. But now there is a second hand at play, ours. We have in our ingenuity and in our hunger for energy fundamentally altered the blanket of air that wraps our world. We have pumped gases into the sky, carbon dioxide, methane, and this blanket has grown thicker. It is a blanket that is very, very good at trapping heat. So all that sunlight, all that energy that should radiate back into space, more of it is staying here. Our atmosphere, our oceans, they are soaking up extra energy, trillions and trillions of watts of it every single second. It is an almost unimaginable amount of power, and that energy does not just disappear, it has to go somewhere. It goes into the air, creating waves of heat that scorch continents. It goes into the water, warming the oceans, especially the surface, turning them from a gentle cradle of life into a superheated engine. This added energy, this human-caused warming, it doesn't create the storms or the droughts, but it amplifies them. It takes the planet's natural heartbeat and turns it into a feverish arrhythmia. It takes a normal storm and loads the dice. It makes it bigger, stronger, slower, wetter, more destructive. It is a dual cause, a natural world now pushed to its limits by the consequences of our own actions. And the results, the phenomena this creates, are staggering. They are forces that rival the drama we see in distant space. Let us think for a moment about a superstorm, a hurricane, a cyclone, a typhoon. The names change with the ocean, but the monster is the one and the same. We see them from space as we did our galaxy's beautiful swirling spirals of white cloud. But they are not gentle nebulae. They are engines of pure heat. They are born over those unnaturally warm oceans. The warm, moist air rises and rises like steam from a boiling pot. As it rises, it cools and condenses, releasing that trapped heat, that latent energy which fuels the storm, making it rise even faster. It creates a vacuum, a void at its center, the calm, cold eye, and all around it the winds rush in to fill that void at 100, 150, sometimes 200 miles per hour. It is a machine, a thermal engine the size of a country. But the wind, as terrible as it is not even the deadliest part. The storm's immense power, its low-pressure heart, pulls the very surface of the ocean upward. It creates a dome of water, and as the storm marches towards the land, it pushes that dome ahead of it. We call it a storm surge, but that is too gentle a word. It is a wall. It is the ocean, the deep ocean rising up from its bed and walking onto the land. It is not a flood. It is a temporary moving sea, 10, 20, even 30 feet high, that scours everything in its path. And then there is the rain. Because the storm is breathing in so much warm, wet air, it must breathe it out. It exhales a deluge, a river falling from the sky. The ground becomes so saturated it can take no more. The water has nowhere to go, and a single storm can change a coastline forever. This is the power of a heat engine, a monster born from a warming sea. But there are other forces even more sudden, even more terrifying. We often think of tsunamis as the children of earthquakes. The great tectonic plates, the skin of our planet, one slips beneath the other, and the ocean floor snaps upward like a giant paddle pushing the entire column of water above it. And a wave of displacement, a silent, fast-moving bulge of water, travels across the ocean. But there is another kind of wave, a mega tsunami. These are not born from the shifting of plates. They are born from a single catastrophic event, a massive displacement of matter. Imagine a volcano, an island volcano growing for millennia, and one day its side collapses. An entire flank of the mountain, billions of tons of rock and earth, suddenly gives way and slides in one giant awful moment into the sea. Or imagine a steep-walled fjord, a bay surrounded by mountains. An earthquake doesn't move the seafloor, it just shakes the mountain, and the mountain lets go. An entire face of rock and ice detaches. The water in that bay, in that confined space, has nowhere to go. It is not pushed horizontally, it is displaced vertically. The water splashes. It's the single most terrifying image I can conjure, a splash on the scale of a mountain. In 1958, in Lituya Bay, Alaska, this is exactly what happened. An earthquake shook loose 40 million cubic yards of rock which fell 3,000 feet straight into the water. It created a wave, a splash that was so powerful it washed up the other side of the bay to an elevation of 1,720 feet. That is more than 3 times the height of the Eiffel Tower. A wave over a quarter of a mile high. It scoured the mountainsides clean, stripping them of every tree, every handful of soil, leaving nothing but bare grey rock. This is a mega tsunami, an event so extreme it seems impossible, a reminder of the sheer raw kinetic power hidden in the earth and rock around us. And in some terrible cases, these events can even be triggered from space, a large asteroid, a comet fragment striking the ocean. The impact would not just create a crater, it would create a splash that would radiate outwards, a mega tsunami that could scour entire continents. These forces, the superstorm, the mega tsunami, they are not just local stories. In our interconnected world, a disaster in one place sends ripples everywhere. The consequences are truly global. Think of our economy, the intricate, delicate web of trade that connects us all. A superstorm hits a vital port, a factory that makes a tiny essential computer chip is flooded. A historic drought withers the grain fields of a major breadbasket. Suddenly the cargo ships stop. The supply chains which we rely on for our food, our medicine, our technology, they snap. The shelves in your local store 1,000 miles away from the flood go empty. The price of bread doubles. A single event in one corner of the world can trigger economic shocks in all the others. And then there is the human cost, the most profound consequence of all. When the storm surge recedes, it leaves behind a land poisoned by salt. When the drought becomes permanent, the well runs dry and the earth turns to dust. When the sea level rises slow and patient, year after year it claims the land inch by inch. The farm that has been in a family for generations can no longer grow food. The village that has stood by the coast for centuries is now part of the sea, and the people must move. This is not a vacation, it is not a choice, it is a displacement. It is the sound of millions of footsteps walking away from their homes, their memories, their ancestors, because the land can no longer hold them. We call them climate refugees. It is a new name for a new and ancient kind of sorrow, a mass migration not because of war but because of water and heat. And finally there is the cost to the silent victims, the environment itself. The coral reefs, those vibrant, impossible cities under the sea, are built by tiny living creatures, but when the water becomes too warm or too acidic, the creatures panic. They expel the colourful algae that live with them, and the reef turns a ghostly white. It bleaches. It is not dead, not yet, but it is starving. And if the heat lasts too long, it becomes a boneyard, a skeleton of what was once a miracle. The great forest, the lungs of our planet, become tinder dry from endless drought. They are not just burned, they are erased. The salt from the sea pushed inland by storms poisons the freshwater marshes, the fields, the aquifers, killing the trees and ensuring nothing can grow for decades. The web of life, which is so resilient, is also so fragile, and we are pulling at all the threads at once. It is a heavy thing to think about. As you lie here safe in your bed to think of such power, such destruction, it can feel overwhelming. It can make us feel small, helpless. But we are not. We are not just the cause of the problem. We are and we must be the source of the solution. Our species is defined by its resilience. We are watchers, we are learners, we are builders, and we are at our very best collaborators. The challenge is twofold. We must adapt and we must mitigate. Mitigation is stopping the problem from getting worse. It is the hard, slow work of weaning ourselves off the energies that thicken that blanket. It is the work of innovation, of finding new ways to power our lives that do not trap the heat. It is the work of a generation. But adaptation, that is the work of now. It is the work of learning to live with the changes we have already set in motion. It is the work of becoming more resilient. And resilience is not just about building higher walls. Sometimes it is. Sometimes it is about amazing technology. It is about satellites that can see a storm being born thousands of miles away. It is about sensors that can feel the slightest tremor in the earth and send a warning in seconds, giving people precious minutes to find high ground. It is about designing buildings that can bend, not break in high winds. But true resilience is often quieter. It is about wisdom. It is about remembering what we used to know. It's about looking at a mangrove forest not as a swamp, but as the planet's greatest natural seawall, its tangled roots capable of absorbing the power of a storm surge far better than any concrete barrier. It's about looking at a river's natural floodplain not as wasted space to be developed, but as the river's essential breathing room, a place for the water to go harmlessly when the rains come. It is about building with nature, not against it. And more than anything, resilience is about us. It is about community. It is about a neighbour checking on an elderly person during a heatwave. It is about sharing knowledge, the wisdom of indigenous communities who have lived with the land cycles for millennia, combined with our most advanced climate models. It's about realising that the borders we draw on maps are meaningless to a hurricane. They are meaningless to a plume of smoke from a wildfire. They are meaningless to a rising sea. We are all of us in this together, in this one fragile, beautiful, and sometimes terrifying home. As you rest here tonight, as you feel the gentle, steady rhythm of your own breathing, hold in your mind the breath of the planet. It is wild, it is powerful, and it is speaking to us. It is reminding us of our own fragility. We are after all a soft-bodied species on a planet of rock and fire and water, but it is also reminding us of our strength. We are not brittle. We can bend, we can learn, we can heal, and we can help to heal. The future is not about conquering nature. That was a story of arrogance. The future is about finding our place within it. It is about respect, it is about humility, and it is about a deep and profound resilience. Let that thought settle, not as a fear but as a purpose, a quiet resolve. We are fragile, and we are resilient. And now just rest. Let the earth turn, let the storms rage far away. Here in this moment you're safe and you can sleep. Let us return now from the dance of galaxies and the birth of stars and pull our gaze back until the entire cosmic web is just a shimmering pattern in the dark. Let us look at the whole vast, beautiful universe and ask the biggest question of all. What is its future? For most of history, we thought we knew the answer. It seemed simple. The universe is full of stuff, galaxies, gas, dark matter, and all of this stuff has gravity. Gravity, as we know, pulls. It is the universe's great brake pedal. When scientists discovered the universe was expanding, they assumed it must be slowing down. The only real question was how much. Would gravity be strong enough to eventually stop the expansion and pull everything back together, ending in a big crunch? Or was the expansion too fast, destined to coast forever, slowing down but never quite stopping like a car running out of gas? It was a good debate. It was the central question of cosmology. And in the late 1990s, two teams of astronomers set out to settle it. Their method was ingenious. They would use standard candles, a special kind of exploding star. These are called Type 1a supernovae. They are wonderful for astronomers because they are all near or far the same. They always explode with the same precise, brilliant brightness. Because we know exactly how bright they should be, we can tell how far away they are by measuring how faint they appear to us. The fainter the light, the farther it has travelled to reach us. The plan was to look at these supernovae in the most distant galaxies. By measuring their faintness, their distance, and the stretch of their light, their speed, they could build a map of the universe's expansion over billions of years. They were looking into the past to see how much the universe had slowed down. The data came in. The astronomers checked their math. They checked it again. They couldn't believe it. There was no way it could be right. The distant supernovae. They were fainter than they should have been. They were farther away than any of the theories predicted. It was like throwing a ball up into the air, expecting it to slow down, and instead, watching it suddenly accelerate, shooting away from you faster and faster into the sky. The discovery was shocking. It turned cosmology on its head. The universe was not slowing down, it was speeding up. In a single moment, our understanding of the cosmos was shattered. The brake pedal was not being pressed. Something somewhere was flooring the gas. But what force could possibly be stronger than the collective gravity of 100 billion galaxies? What could be pushing the fabric of space apart? Scientists gave this something a name that perfectly captures our confusion. They called it dark energy. This is not the same as dark matter. Dark matter, as we've learned, is the scaffolding. Its gravity pulls things together, holding our galaxies in one piece. This dark energy is the opposite. It is a repulsive force. It is an anti-gravity embedded in the very fabric of space itself. And when they did the math, the shock only deepened. This force wasn't just a tiny, strange effect on the edge of the cosmos. It was by far the dominant thing in the universe. Your body, this planet, the sun, all the stars, you can see all the gas and dust in all the galaxies. That's only about 5% of the universe. Dark matter, the invisible glue, makes up about 27%. The rest, roughly 68% of everything, is dark energy. Think about that. You and I, the Earth, the Milky Way, we are the leftovers. We are just a rounding error. We live in a universe whose destiny is not controlled by the matter we can see, but by an invisible accelerating shadow. And the strangest part of this whole story, Albert Einstein saw it coming. 100 years ago, when Einstein first created his equations of general relativity, they told him something he didn't like. They said the universe must be either expanding or contracting, but at the time, everyone including Einstein believed the universe was static, eternal and unchanging. So to make his math work, to fix it and hold the universe still, he added a new term. It was a small repulsive energy that would perfectly balance the pull of gravity. He called it the cosmological constant. A few years later, Edwin Hubble proved the universe was expanding. The universe wasn't static after all. Einstein, embarrassed, removed the term from his equation, supposedly calling it his biggest blunder. He threw it in the trash, and for almost a century that's where it stayed. Until the 90s, until those distant supernovae. Suddenly astronomers rushed to dig Einstein's blunder out of the trash. It was the perfect description of what they were seeing. This cosmological constant was the dark energy. It is perhaps the most profound and simplest idea in all of physics. It is the idea that space itself has energy. It is a cost of existing. For every cubic meter of empty quiet vacuum there is an inherent fundamental energy, and this energy has a very strange property it pushes. This is what leads to the acceleration. As the universe expands, it creates more space, and this new fresh space comes with its own dark energy. So the more space expands, the more dark energy there is, and the faster space expands. It is a runaway feedback loop. The universe is making more of the very stuff that is pushing it apart. If this is true, if dark energy is this constant unchanging property of space, then we know our future. It is a future of profound, cold and infinite loneliness. It is called the Big Freeze. As the universe accelerates, the galaxies we see tonight will be pushed away from us faster and faster. First, the most distant clusters will cross a cosmic horizon. Their light will be stretched so thin, receding so quickly that it will no doubt be able to reach us. They will vanish from our sky as if they never existed. Then closer clusters will follow. One by one, the lights in the cosmic neighborhood will go out. Even our nearest neighbor Andromeda, which is currently speeding toward us for a magnificent collision, in a few billion years will eventually be overwhelmed. The expanding space between our two galaxies will become so powerful that it will reverse Andromeda's course. We will watch it slow down, stop, and then begin to drift away from us forever. Eventually the sky will be empty. Our Milky Way will be a single isolated island adrift in an endless, accelerating dark void. All other galaxies will be gone, pushed beyond the reach of our most powerful telescopes, beyond the reach of light itself. Inside our lonely galaxy, the stars will burn out. The universe will grow cold, dark and quiet. It is not a violent end, it is a slow, gradual fade to black, expanding for all eternity. But what if dark energy is not constant? What if it's not Einstein's blunder? What if it is something that changes over time? What if it is growing stronger? This leads to a different, far more terrifying fate. This is called the Big Rip. If dark energy is a phantom energy that increases in strength, its repulsive force will eventually overcome everything. First, its push would be stronger than the gravity holding clusters of galaxies together. The great superclusters would dissolve. Then, as the energy intensifies, it would become stronger than the gravity holding our own Milky Way together. The galaxy would be torn apart, the spiral arms would unwind, and the stars would be flung into the darkness. It would not stop. In the final terrible days of the universe, the dark energy would be stronger than the gravity holding our solar system together. The Earth would be ripped from the sun, sent tumbling into the void. The moon would be torn from the Earth. In the last few minutes, the force would be stronger than the chemical bonds holding the planet together. The Earth itself would disintegrate. And in the final fraction of a second, the dark energy would be stronger than the forces holding you together. The very atoms that make up your body would be torn apart. Space-time itself would unravel. Which fate is ours, the long quiet freeze or the violent sudden rip? To find out, we need to know the exact rate of the universe's expansion. We need to measure it perfectly. And this is where today we are faced with the biggest puzzle in all of science. It is a profound disagreement, a crisis in cosmology. We call it the Hubble tension. We have two excellent, precise ways to measure the expansion of the universe. First, we can look at the early universe. We look at the baby picture of the cosmos, the cosmic microwave background, the afterglow of the Big Bang. By studying the patterns in this ancient light, our best theories of physics can predict exactly how fast the universe should be expanding today. Second, we can look at the late universe, the adult universe. We can use those same supernovae and other bright stars in nearby galaxies to measure the expansion rate right. Here is the problem: the numbers do not match. It is not a small error. The measurements from the early universe predict a slower expansion rate than the one we are measuring today. The two most precise measurements in all of science are telling us two different things. This means something is fundamentally wrong. Either our measurements of the past are wrong, our measurements of the present are wrong, or our understanding of the universe, the one that connects the past to the present, is broken. This tension has opened the door to wild new ideas. Some scientists wonder if dark energy even exists at all. What if the problem is not a new thing, but an old thing we have misunderstood? What if Einstein's theory of gravity is simply incomplete? This is the theory of a modified gravity. Perhaps on the very largest cosmic scales, gravity just doesn't work the way we think it does. Maybe it gets weaker over vast distances, allowing the universe to expand faster than it should. We wouldn't need a gas pedal, we would just have faulty brakes. Or perhaps dark energy is real, but it's not a constant. Maybe it is a dynamic changing field that fills all of space like a thin, invisible fluid. This idea is called quintessence. Unlike Einstein's constant quintessence could change over time, it could have been weaker in the past and is growing stronger now. This might be the answer to the Hubble tension. It would also mean the fate of the universe is not yet written. It all depends on what this field does next. It all leaves us in a place of deep, profound humility. We are left staring at one final unsettling question. Why is the amount of dark energy so perfect? It is a tiny number. It is so small that it's almost zero. If it were just a little bit stronger, its repulsive force would have been so powerful that it would have torn the universe apart at the very beginning. Stars and galaxies would have never had a chance to form. No gravity, no planets, no life. If it was zero or negative pulling, the universe might have just collapsed back in on itself long before life could ever have emerged. And yet here we are. We live in a universe that is balanced on a razor's edge, with a value for dark energy that is just right to allow for stars, galaxies, planets, and us. Why? This is the anthropic principle. It is a controversial, philosophical, and powerful idea. It suggests that we shouldn't be surprised. The very fact that we are here to ask the question means we must exist in a universe that is hospitable to us. If you imagine a multiverse, an infinite ocean of other universes, it's possible that most of them are sterile. Most of them have dark energy values that are too high or too low. They are born and die empty and dark. But in a tiny fraction of them, by pure cosmic chance, the number is just right. And in one of those lucky universes, here we are. We are here looking at the sky because this is one of the few universes where here is a place that could exist. We end then where we began, on a small blue world looking up at the night sky. We thought we were studying the stars, we thought we were studying the light, but we have discovered that we are in fact living in a universe dominated by shadow. 95% of the cosmos is a complete, absolute and total mystery. There is a dark, invisible scaffold holding our world together, and there is a dark, invisible shadow pushing our world apart. We are small, yes, but we are also the universe's way of knowing itself, and the fact that we can lie here in the quiet and even comprehend the scale of this mystery, the fact that we can name the shadows even as we stand within them, is in itself a miracle. The shadow is vast, the night is deep, but it is here in the darkness that the greatest secrets are waiting, and it is here in this quiet cosmic shadow that you can rest, you can let go, you can sleep. And so we find ourselves looking out into that deep quiet ocean of space. We've talked about the great islands of light, the galaxies and the vast distances that separate them. It seems so still, so silent. But is it? For as long as we have had the tools to listen, we have pointed them toward the stars. We listen for the hum of the ancient light, the echoes of the universe's birth. And sometimes in that profound quiet we hear something that doesn't fit. In our journey, we have built incredible maps of the cosmos. We have theories that act as our guides, telling us what we should expect to see. We expect stars to burn a certain way, planets to move in predictable paths, and the static of space to sound like, well, static. But the universe is not obligated to follow our rules. And the most exciting moments in science, the moments that change everything, often begin not with a loud discovery, but with a quiet whisper, a single note that is out of tune. We call these anomalies. An anomaly is simply something that doesn't fit the pattern. It's a puzzle piece left over after the picture is finished. And this is where the true heart of discovery lies. It's easy to celebrate what we know. It is much harder and much more profound to sit with what we don't know. When a scientist finds an anomaly, their first instinct is not to shout that they have found aliens or a new law of physics. No, the first instinct is much more humble. The first instinct is doubt. Did I make a mistake? Is the telescope blurry? Is the computer code wrong? Did someone nearby turn on a microwave oven and mess up the signal? This is the most important part of the process. We must first try with all our power to prove that the strange new thing is in fact not strange. We must try to explain it with everything we already know. We must rule out every boring, simple human error, because only after we have failed to find a simple explanation, only after we have checked our math and checked our equipment and checked our assumptions and the anomaly still remains, only then can we allow ourselves to whisper a single thrilling word, what if? What if this is real? What if the universe is trying to tell us something new? This is the story of that what if. It's the story of the echoes we have heard in the void, the strange whispers that came and went, leaving us with more questions than answers. Imagine the year is 1977. A radio telescope called the Big Ear is listening. It doesn't look like a modern satellite dish. It looks like a giant flat field, a grid of metal fence stretched across the ground pointing up at the sky. It is not actively searching, it is just listening. It waits patiently as the Earth itself turns sweeping its gaze across the galaxy. A man named Jerry Eman is looking at the data. In those days, data didn't appear on a bright glowing screen. It was printed out by machine line by line on long sheets of paper. It was mostly just a jumble of low numbers and letters representing the quiet background static of the cosmos. It was a gentle, constant hiss, and then he saw it. On the printout there was a sequence, a series of letters and numbers that were not quiet. They were loud. The signal was so strong, so powerful that it leapt off the page. It was a spike, a sudden shout in the middle of a quiet library. The signal lasted for 72 seconds. As the Earth turned, the Big Ear's view swept across a patch of sky in the constellation Sagittarius. The signal appeared, grew stronger and stronger, reached a powerful peak, and then faded away exactly as you would expect a signal from deep space to do as the telescope's view moved past it. Jerry Eman was so stunned that he grabbed a red pen. He circled the sequence on the paper, and in the margin he wrote a single word, "Wow." That is what we have called it ever since, the wow signal. But what made it so special? It wasn't just that it was loud, it was where it was. It was broadcasting on a very specific, very special frequency. It was at or very near the frequency of hydrogen gas. Hydrogen is the simplest and most common element in the entire universe. It is the atom that all stars are made of. This frequency, about 1420 megahertz, is a protected slice of the radio spectrum. It's like a quiet nature preserve where no one is allowed to build. Astronomers call it the water hole, a place where all life might hypothetically come to drink. If you were an intelligent civilization and you wanted to send a signal, a beacon, a simple hello across the stars, this is the exact frequency you might choose. It's the universe's most obvious calling card. And for 72 seconds that calling card was ringing, and then it stopped. The mystery of the wow signal is not just what it was, but that it never ever happened again. We have pointed our telescopes, much more powerful ones, at that same patch of sky. We have listened for days, for months, for decades, and there is only silence. So what was it? Was it a rare, unknown natural event, perhaps a massive, undiscovered type of pulsar? Some scientists have suggested it could have been the gas cloud from a passing comet, though that theory has been heavily debated. Was it interference, a secret military satellite, or a signal from Earth bouncing off a piece of space junk? We have tried, but we cannot find a good match for it. Or was it exactly what it looked like? A brief, powerful, intentional beacon from someone or something far away, a message in a bottle that washed up on our shore for just over a minute, only to be swept back out to sea before we could read the name of the sender. We don't know, and that is the beautiful, frustrating power of the wow signal. It remains a single, tantalizing data point. A whisper that we heard once long ago that reminds us that the void may not be as empty as it looks. It asks us to be patient. It asks us to keep listening. For 40 years, the wow signal was our most profound anomaly, a mystery of sound. Then in 2017, we found an anomaly not of sound, but of substance. This time we didn't hear it, we saw it. It was a faint tiny speck of light moving very, very fast. At first astronomers thought it was just another asteroid, or perhaps a comet from the cold outer edges of our own solar system. But as they tracked its path, they realized something was very, very wrong. It wasn't circling our sun in a long, graceful loop like a planet or a normal comet. Its path was a sharp, open-ended line. It was coming in hot, slinging around our sun and heading back out again, never to return. It was moving too fast to be trapped by our sun's gravity. It was not one of ours. This was the very first object we had ever seen with our own eyes that we knew with absolute certainty had come from another star system. It was a visitor from interstellar space. The astronomers who found it in Hawaii gave it a beautiful name, Oumuamua. It means a messenger from afar arriving first. And what a strange messenger it was. The longer we looked at Oumuamua, the stranger it became. First there was its shape. We couldn't see it up close, of course. It was just a dot of light. But we could see its brightness change, and it changed dramatically. It would get very bright, then very dim, very quickly tumbling end over end. This told us it was not a round ball like a normal asteroid. It had to be a very strange shape. It was at least 5 times, maybe 10 times longer than it was wide. We pictured it as a long dark cigar or perhaps a thin flat pancake tumbling through our solar system. We had never seen anything quite like it. Then there was what it didn't do. It passed very close to our sun, an object coming from the deep cold of interstellar space when it gets that close to a star, though, should warm up. If it had any ice on it, like a comet, that ice should have turned to gas, creating a beautiful glowing cloud and a long bright tail. We call this a coma. But Oumuamua had no coma, no tail. It was dark, it looked like a dry dead rock. This was a puzzle. If it was a dry rock, where did it come from? But the biggest puzzle was yet to come. As Oumuamua passed the sun and began its long journey back out into the void, astronomers watched it closely, and they noticed something that made the hair on their arms stand up. It was accelerating. It was moving away from the sun faster than it should have been. Something was giving it a small, gentle, continuous push. This is the heart of the anomaly. This is the part that doesn't fit. We know what pushes things in space, gravity. But this push was not gravity. Our calculations of the sun's gravity and the gravity of all the planets were perfect. This was something else. So what was it? If Oumuamua had a comet's tail, this would be an easy puzzle to solve. Comets accelerate all the time. The gas and dust spraying off their surface, heated by the sun, acts like a set of tiny rocket thrusters. It's called outgassing. But Oumuamua had no tail. We looked. We could not see any gas. So what could be pushing it? Pushing it. This is where the scientific imagination, the what if, begins. One idea is that Oumuamua was a very special kind of iceberg. Not an iceberg of water, but perhaps an iceberg made of pure frozen nitrogen or frozen hydrogen. These ices would evaporate or outgas when warmed by the sun, but the gas they release would be completely invisible to our telescopes. This invisible outgassing would give it the gentle push. It would perfectly explain the speed, the lack of a tail, and even the strange shape. It's a clean, elegant, natural explanation. A nitrogen iceberg wandering the galaxy for millions of years. But there is another idea. An idea proposed by an astronomer at Harvard named Avi Loeb. It is an idea that is much more dramatic. He asked, what else do we know of that gets a gentle push with no visible tail? Sunlight itself. Light is made of particles. It has energy. When it bounces off something, it gives it a tiny, tiny push. This push is so small that it can't move a big, heavy rock. But what if Oumuamua wasn't a heavy rock? What if it was very, very thin? What if it was a solar sail? A solar sail is a technology that we humans are trying to build right now. It's a way to travel between the stars. You build a massive, thin, lightweight sheet like aluminum foil, and you let the light from your home star push you faster and faster out into the cosmos. What if Oumuamua was not a natural object at all? What if it was a piece of technology, a piece of debris from a long-dead civilization, or perhaps even an active probe, a messenger sent to our solar system on purpose? This idea is, of course, very controversial. Most scientists quite rightly favour the nitrogen iceberg theory. Science must always favour the simplest, most natural explanation. But the story of Oumuamua is not important because it was aliens. It is important because it forced us to consider the possibility. It forced us to confront the fact that our solar system is not a closed box. We are part of a wider, stranger galaxy. And sometimes things from out there will drift in here. And so Oumuamua is gone. It is now too far, too faint to see even with our best telescopes. It is drifting back into the dark, carrying its secrets with it. Like the wow signal, it is an echo that has faded. These events are a profound reminder of our place in the cosmos. They teach us humility. They teach us patience. The universe is under no obligation to give us easy answers. It does not send us messages that are clear and simple. Instead, it offers puzzles, whispers, anomalies. It gives us a 72-second signal from Sagittarius. It gives us a strange, tumbling visitor from another star. These are the moments that keep us awake, looking and listening. They show us that the universe is far more creative and far stranger than we have yet imagined. We live in a time of great discovery, but we are in truth just beginning. We are still the small child standing at the edge of a vast, dark ocean. We have found a few strange shells on the beach, things that washed up from a place we cannot see. We do not know what else is out there in the deep. We do not know what other messengers are on their way or what other signals are at this very moment, washing over our planet, waiting for a listener patient enough to hear them. Our job is not to have all the answers. Our job is simply to be present, to be curious, and to keep our instruments pointed at the sky, to listen with patience and with wonder for the next echo in the void. And so our journey through the cosmos for tonight begins to draw to a close. The great tapestry of stars and silence settles around us, and the quiet of the room feels a little deeper, a little more connected to the vast quiet outside. We have travelled so far just by letting our minds wander. We stood together at the strange crossroads of reality, thinking about those whispers of parallel worlds. The idea that another you might exist, living a different life, making different choices, is a dizzying thought, like looking into a hall of mirrors that stretches into infinity. But it also brings a strange comfort. It suggests that every possibility, every path not taken might be playing out somewhere. It means the universe is a place of infinite stories, not just one. And as we rest, perhaps we can feel a strange faint kinship with those other selves, all of us, part of a grander, unseen whole. We strained our ears, listening to the great, profound silence of space. We wondered about other minds, other civilizations separated from us by gulfs of time and distance so vast they are almost impossible to imagine. We thought about the hopeful signals we send out like messages in a bottle tossed into a cosmic ocean. And we thought about the strange fleeting whispers the universe sends back, those little puzzles like the wow signal that hint at something or someone else. It is the loneliest thought perhaps that we might be alone, and it is also the most exciting thought that we might not be. In this stillness we can hold both ideas at once. We returned our gaze to our own home, this beautiful blue-green world. We remembered that we are living on a planet that is itself a miracle, a complex breathing system of rock and water and air. We thought about the immense power simmering beneath our feet, the slow dance of continents, the sudden fury of a volcano, the gentle life-giving cycle of water. We are not just on the earth, we are the earth. Its iron is in our blood, its water flows through us, its atmosphere is our breath. To feel the ground beneath us is to feel a connection to a life story 4.5 billion years long. And we looked into the darkness, the great invisible mystery that holds it all together. We spoke of the dark energy that gently pushes galaxies apart, stretching the very fabric of space, accelerating the universe toward an unknown future. We wondered about the dark matter, the invisible scaffolding that gravity uses to build the beautiful spiral cities of stars we call galaxies. Most of everything we realized is hidden from us. We are participants in a grand play where we cannot see most of the stage or most of the other actors, and yet we are here aware of the mystery. All of it, all these thoughts, all these wonders. It feels like we are standing on a small island. Let us call it the island of knowing. This island is where we live. It is a warm, well-lit place. It's built from everything humanity has ever learned. Its foundations are the steady laws of physics, the equations that predict the fall of an apple and the orbit of a planet. Its structures are the stories we tell, the art we create, the history we remember. The lights of our cities and our campfires burn brightly here. We are safe on this island. We understand more or less how it works. We have mapped its coasts and explored its inner jungles. But all around us, surrounding this small island, is the vast, dark, endless ocean of the unknown. It stretches further than our strongest telescopes can see. It is deeper than our most complex theories can probe. We can stand at the shore of our island and look out, and we see no end to it. Out there in that great ocean are the answers to all the questions we have just asked. The truth about other worlds, the signals from other minds, the true nature of the darkness that shapes the stars. In the past, perhaps we were afraid of this ocean. It seemed cold and threatening, but tonight as we rest, it doesn't feel that way. The air coming off it is cool and clean. The sound of its waves breaking gently on the shores of our knowledge is not a threat. It is a lullaby. It is a song of possibility. Every question we ask is a small boat we send out into that ocean. Every scientist, every artist, every child who looks up at the sky and asks, why, is a brave explorer dipping their toes into that water. Sometimes our boats come back carrying new knowledge, and our island grows just a little bit bigger. A new piece of coastline is formed, and sometimes our boats simply sail off beyond the horizon, and we are left to wonder, to imagine. And that's the most human thing of all. In the silence of the night, as your breathing slows and your body grows heavy with rest, it is this sense of wonder that connects us. It connects you to me. It connects us to every person who has ever lived and looked up at the moon. It is the thread that ties our small waking minds to the vast dreaming universe. You do not need to have the answers. You do not need to solve the great mysteries. All you have to do is be here on this island listening to the ocean, to know that you are a part of a story so much bigger than yourself. You are a way for the cosmos to know itself. Every atom in your body was forged in the heart of a dying star billions of years ago. You are quite literally stardust alive and thinking. So as you drift off, let these big questions become soft and distant. Let them become part of the background like the gentle hum of the stars. Feel the weight of your body, the warmth of your bed. Feel the simple, steady rhythm of your own breath in and out. You are safe. You are part of it all. And the ocean of the unknown will be here tomorrow waiting patiently when you wake. Good night, sleep well.